vraiment? Oui.
Okay.
Which size?
That started actually.
Pardon?
We have started.
We've started?
Yes. Yes. And this is the
I knew
English
that.
section.
I knew that. Okay.
All right.
Bonjour.
Hi everyone.
Hi everyone, hi Guy-Vincent.
Hi Marcel. Okay, so today we want to give you a short overview of the first assignment, which was assignment 0. And so we'll just go quickly over some solution that we created. The solution is also posted on GitHub right now, so you can grab it if you want, and you can follow along from there.
We will also possibly look at the object-oriented version of the assignment 0 if time allows.
Yes, if time allows.
And we'll spend a little bit of time talking about the assignment 1, which is the one where you're going to get marks for.
Absolutely.
Absolutely.
So we still should have the comments that you guys are typing here. So live chat, if there is a problem, if you can't hear us, if you want something is not clear, if you put it there, we should see it.
Yeah, you might have seen that we've changed the setup a little bit. We're in my office, so
much cleaner.
If the sound is not proper, just write a line on the chat.
Absolutely.
All right, so probably we should get going.
Let's start.
Okay, so
we had a set of files that were given to us, and which is here. So these are the files that you got from us. We got Utils, we got student info, and we got this larger file right there.
Yes. So the first thing, I guess, would be to try to compile these things. So where am I? I'm here, ls. I see all 3 files that we provided you. javac. I can use the star if I want to compile all these things at once. And then I see some error message. So as you know, we've been we've been insisting quite a bit that at all time your program should compile. You're only adding incrementally to the code 1 line at a time.
That's right.
So right now it's not compiling. We've always said that it's very important to learn to read these error messages that are provided by the compiler. So here it says on line 160 of ITI1121 we're missing a return statement.
Right. So
if we go right here, line 160, we see it. We see there was a comment that says your code should be inserted here. The method cleanup board returns the reference of an array of characters. So therefore, we're not very surprised that the compiler is saying that there's a problem. We're not returning anything. Similarly, if we go maybe to the shell, we see that there's a second error message, although we're always saying that you should only consider 1 error message at a time. Here, I think it's safe. It's saying that on line 178, we're also missing a return statement.
All right, yes, so and 178 is right there. So this is this method, also a method that you are supposed to fill in, and if you look at it, it is a method that as a type, it returns a boolean, and so, well, that's probably why the compiler is not happy with us. We are not returning anything.
Yes, and so you're going to be facing this very same thing for every assignment where we're providing some code. First thing is to make sure that this thing is compiling. So there's many ways that you can achieve this, one of which would be to remove all these methods that are there, throw them into a separate file, and reintroduce one by one the methods in a logical order. That would be one way. Another way would be to comment out, to put some comments in front of these methods. However, that can be a problem, because if I'm putting comments in front of the declaration is rigorous, if is rigorous was called from the code somewhere else, then the other method will not, the method that's calling is rigorous, would not compile. And so there could be this kind of domino effect where I would have to comment out all of the code. There's another way around that's very easy that every programmer is using. We're calling this stubs. So we're saying, let's just create a shell for the method. Let's make sure that the compiler is happy. Here, to make the compiler happy for is rigorous, we simply have to return a Boolean value. Here I can return true, we could return false. This is quite dangerous though, because later if we forget to implement the actual method, we're going to be in trouble. I would suggest that we do something like system out, print line, and then insert here a message that will be reminding us that we should be implementing this. So something like, don't forget to implement this. So here you see I'm using capital letters to really
There's too many.
this. So I'm really making sure that I will see what's going on. Similarly here, it's a little bit more tricky because the type of the return value is the reference of an array of characters. I could create some kind of array and return the reference, but there's also this special value, so return null. Here I'm saying I'm not returning the reference of an array. I'm not. This value is a special value that says not pointing at anything.
That's right.
In principle with this,
so you should probably also have this print statement saying that you should not forget this one either.
yes, good point. So very rapidly copy this over there. Here you see probably I should have personalized because I don't know which one it is. So clean up, just one P would be enough. Clean up board, something like this.
Right.
Is rigorous, like this. Okay, so that should do.
All right, so now it should compile, or at least those problems that the compiler were before should have been addressed.
Okay, so that compiles.
That compiles.
Why don't we talk about student info right away, because it's a very simple thing. It's something that comes up with every assignment. So this is a very simple thing where the expectation is that you're going to complete the method display by inserting the names, student IDs of the two team members. So here that would be something like Guy-Vincent, Jordan,
Yeah.
and Marcel.
So Marcel is Turcotte is just one R.
And we're not going to put our employee numbers there.
Let's not.
But we're expecting you to put your student number there. What's the idea with this? The idea, I like to have things aligned. The idea is that in the main method here of all our programs, we will always very systematically call studentinfo.display so that when the TA executes your program, immediately on the console it shows who the students are, and so it makes the life of the TA easier.
Right. So now it should work. We can compile again, and we have that, and we should be able to run it, right? So the main was in ITI. In ITI, there you go.
All right, cool.
So it's working. We have our name, and then it says welcome to my concentration game, which is the beginning of this method here, the constructor of ITI1121A3. Shall we go over utils a little bit before we do the...
Yeah, let's start simply. So we provided you a class here that defines essentially a few methods that we thought were useful for you. So read all and shuffle array. So here, as you can see, reading information in Java is a little bit tricky. We're going to look at that later. To read data from files or requires some understanding of a concept called exceptions, and we're going to look at exceptions after we've talked about stacks in class. Okay, so that's why we created utils, so that you don't have to be concerned about the various ways of reading information. Do you want me to do a little test of this?
Let's try a test, yes.
Okay, so
a quick one.
A very quick one. So I think it's always a good idea to test things independently of your program so that you can make sure that everything is working the way you expect. So public static void main string like this, args like so. I need to save this somewhere. Is it the right? I think so. Just need to give a name, test.java.
Right, let's see if it's here.
Is it there? It's there, Java C, test, it compiles. Fantastic.
We are in business, okay?
And here what we can do is maybe just one little test, which is right here. Okay, so I want to test the utility for reading lines. And so I'm going to have a simple thing here. Public static void. I'm calling it test read all lines. Read all lines has no parameters. String lines. So I'm going to use the reference variable lines to point at the result of a call to utils read all lines.
So that's the method that was provided, read all lines, which takes as a parameter the name of the file that you want to read.
So now I need something to read. Maybe I can read the file that I'm working on, test.java.
Okay.
So this way it's going to be quicker.
So that would be lines, not line.
Okay, lines, good. Let's see if this compiles. It does. We need to call the method. So test read all lines Voila. So compile. It seems to work, but I don't know if it really works. So I'm gonna print all these lines very rapidly. So for int I equals 0, I smaller than lines dot length. So I'm asking the array, what's your length? I plus plus, like so. And I will simply print, so system out print line. Here I could print simply lines of I like this, and that would work. I'm a little bit up.
So there is a parenthesis here.
Oh, okay, an extra. Okay. So I could do just this, and it would be just fine. Or not. So I guess print requires a T. Okay, so that would work. And if we say Java test, it seems to work. Because I'm a little bit an excessive person, I tend to do this when I'm printing the content of some files. I'm adding these little square brackets
Plus.
so that if there are extra space that I don't want to have in my file, they will become visible. So Java.
So here you're creating a program that reads itself.
So here we see there was no space on these lines, so I clearly see everywhere that where the spaces are when they're not, and all that. All right, that's good. So you could do the same thing for testing the other method in utils. We're not going to do that, but you could.
Absolutely. All right, so now we want to try to solve this assignment. And so if we look again at what we had here, I'm not going to really check the Python code and compare it because we don't have that kind of time. I assume you have looked at the Python code already. So we'll just try to fill out some of the methods. Sometimes I'm just going to copy over the solution because it's kind of repetitive and we don't have the time. Okay, so let's see. This is the file that we got. It uses a scanner here at the top. It imports this package scanner. We are going to use that to read user input. The class is called ITI1121. Very good. We add several methods that were already provided to us, like this one here, create board. Create board takes one parameter, the size of the board. It is the method that is used in order to generate a board that is a valid board of that size. So, and you can see that it returns a reference to an array of characters of primitive char, and so that is going to be the board. So in this particular implementation, we are using arrays of characters to store what corresponds to the playing cards, and each character has the face value of that card. Okay, so there is a little bit of a test here to make sure that size board that you receive makes sense. What do we have? Well, we need a size that is more than 0. 52 is the maximum number of cards we could have here, and there is this little test here which makes sure that this is an even number.
Yes, because the memory game, as you know, requires you to match pairs of cards. So if we had an odd,
that would be difficult to
yeah,
to win. All right, so it just makes sure that this is a valid call, and if not, says something, complains, and return no. Okay. Then what we have here is the creation of the array of the right size, and board is pointing at this array that was just created. And then, so you have here a little bit of a weird thing where you take the character. So with a single quote here, it means a character. Remember that in Java, single quote character. Double quote would mean, okay, this is adding too many things here, but this would be the string A. So you have to be very careful.
You want to compile it, or? Yeah.
Sure. So if I do that, so if you save.
So the expectation would be that you cannot. So if we compile ITI this.java, we're getting an error. You cannot transform the reference of a string into an integer value.
Yes, that makes no sense. But you can do that for a character, because, well, a character is basically a code value, which is an integer. So you can get this value, which here, because it's an uppercase A, is going to be, well, the same in ASCII and in Unicode, and you get that value here, and then the idea is you convert it from character to integer, but you can also do the reverse here, so to convert from integer to character, and that's what we're going to do. So we start from the code of uppercase A, and we're going to put it into our board at the index 0 and also in the middle. This would be, the index 0 plus half of the size, so it will be in the middle of the board. You add this character twice, so you have a pair, and then you're going to add 1 to the code and keep doing that. So then you have the code that comes right after uppercase A, which is uppercase B, and so on and so forth. So you are going to go over all your letters here. Okay, so that's what this does, and then afterwards it returns a reference to the board you just created. Print board does, well, it does print a board on the console, in the standard output. If you read this code here, it's slightly more complicated than the code you had in Python. It's not because it needs to be more complicated, it's just because this will actually only print 10 cards per line. So it will simply print 10 of them, then go to the new line, and then print again, and this will adapt to however many cards you happen to have in your board. So that's why it's a little bit.
Yeah, it's simply a prettier display.
That's right. It's not very important. We were provided wait for player. Wait for player is simply getting, so it prints press enter to continue, and then it waits for the user to press enter. Okay, clear screen will simply print 50 lines, empty lines, and they should push up whatever was printed there. So it's not really cleared, but it's up there. You won't see it unless you
have a big screen.
Unless you have a big screen. All right, print revealed is not provided. So to read a board from a file name that was provided, so this can be done. Cleanup board is not provided. This rigorous is not provided. Play game is not provided, and this is now the starting point. So let's do that. So as you recall, this game starts by asking which of the two possibilities you want to play. You can either get the card generated for you, or you can read the cards from the deck of cards from a file. So we are going to do the first one first. We are simply going to get the card we will generate our code here. So the first thing to do is to type some of these codes. Okay, why is it jumping on me? I'm not sure, but so oops, sorry, I think I've here. Okay, sorry, let me redo that here. There you go. So this is the text that you were asked to print, and you basically want to ask the user, to type 1 or 2. And here, what we want to do is get the answer from the user and basically iterate until until the answer is either 1 or 2. I see that there is someone asking where the GitHub is. It is provided. It is on my Brightspace. I wonder if this is on my website. If someone can put that in the comments, I would be appreciated. Otherwise, I will give you that at the end. I'll send a link here.
Yeah, on Piazza, maybe we can do a follow-up and post these links.
Absolutely, yes. Okay, so basically we are going to ask the user to give us a choice. So let's have a variable choice that is going to store this answer, and we are going to get it choice. So we have printed this information to the user, and then we are going to get the input from the user. So next int. So this will read an integer from the standard input. Note that this will actually crash if you read something that's not an int, and that's fine. We are not here. We want to have some level of control in that if the user is entering an integer which is not 1 or 2, we will do something about it. But if the user enters something that's not an int, then we are not trying to solve that problem here.
No, until we have seen in class the exceptions, we're going to assume that the input is properly formed, that there's no error, because the proper way to deal with error situations in Java is to use exceptions, and that will be seen later.
Absolutely. Okay, so now what I want to do is get this input from the user and basically iterate, asking it again and again until the answer that is provided is either 1 or 2. So you have different ways of doing it. Let's see one. So while the choice that is provided by the user is not 1, and the choice is not 2 either. So it's going to be an integer, but it's neither 1 nor 2. And when that is the case, then I will write something, system.out.print, and this, I'll say something, wrong choice, and maybe provide the choice that was provided here. Okay, why did I? And then try again. Okay. All right. Why this happened? And then Then I have to get this choice again. So choice equals sc.nettic. And so this, if that works, I should be basically stuck in that loop until choice, the information that's provided by the user is either 1 or 2.
Correct.
We can try that. So I compile that again, and I execute it. Oops. Okay. No, we haven't executed it yet. ITI. Come on. Okay. So 1 or 2. So if I try 0, wrong choice, 0. 4, wrong choice, and if I try, for example, 2, that works.
Cool.
Okay, so we are almost done. Now we have to do two different things. If the choice that is provided is 1, then we need to generate the deck automatically. Else, we want to read from a file. So if choice is 1, so here again, choice is a primitive variable, so I compare it using equal directly. I want to see if the value that is currently inside choice is 1. So here, if that's the case, then the next thing is to ask the user how many elements should be in that deck. And again, we need to make sure that this value is acceptable. So I'm just, because it's very similar to what we just did above, I'm just going to put directly here that code here. So, but let's read it. So you choose to have generated deck, then, so you see here the difference between there and there. There's a little bit of a subtle difference. Here you read a choice, and then you are going to iterate if the choice that was provided is not the right one. So you don't necessarily go into the loop at all if the choice was good right from the start, because you have got the choice before the loop. In this case, it's a bit of a different approach where we are going to iterate the loop until this provided answer is correct. So here what is done is a little bit of a trick where the size that you are reading is initialized to a value that is going to fail that test. So you know that you will go through that loop at least once.
Yeah, so this is a negative value is not a valid value for size. Sometimes we call these values sentinel values. So
that's right.
All right.
Okay, so if you read that, you can see that this will necessarily go through the while at least once, and in fact it will iterate until you have an even number, which is between 1 and 52.
Yep, absolutely.
All right, and so, well, I just copied it from there, so hopefully it works. And once you have that, then the goal is to generate the deck. And to generate the deck, we have this call here, create board. Yep. So we're just going to use it. So I'm just going to say, so the board is stored into this variable board here. So board will get this create board, and the value, the parameter is the size. Okay. So this should create a board for me, and as I am trying to debug that, I want to see what I got, and well, so happened that there is this handy method here, print board. So even though in the final version you don't want to print the board, maybe for now it would make sense to have a call to print board right there, so we can see what was generated and make sure that our code is correct. So print board, and then the board here. Okay, that should work.
Yeah, should we play?
Let's try. So I compile it.
Cool.
So I need to answer 1 in order to go through my if statement. I need an even number between 1 and 52.
How about 3?
3? How about that? Oh, guess what? Nope. All right. So how about 22?
Cool.
Here you go.
And we see the pretty print.
And we have a pretty print for those 22 cards, and you can see that, you know, as expected, it starts with A, which is at the beginning and in the middle, A, B, B, C, C, etc., etc. So that does work.
So I guess this is a very simple game now. It's a game where the cards are all in increasing order.
That's right. So maybe we want to solve that problem. So what we are going to do after that, so we have created a board. Okay. Let's see if we can do something. So that's the case when the person answers 1. If the person answers 2, then you have to read the board from the file. And then in both cases afterwards, you have to play the game. So here we have a board. We could keep going and play the game from there. But really, if we were to do that, then the code that we would write here would have to write again after reading the file.
Correct.
So that's not a good idea. A better idea would be to have an else section here, which is when the choice is 2. And we know, by the way, that the choice, we could test if choice is 2, but it can only be 2 because it's not 1. And we know that after this line, it was either 1 or 2. And here, we would need to put the code to read from file. But we don't want to do that right now because we want to keep going and implement the game. So we will leave that. And there, we want to start playing the game. So in order to play the game, well, there is this method here, play game, which gets our board as a parameter. So I have to call play game, passing my board that I created, and board, and the, let's see here. All right. Now, as you pointed out, right now the board is sorted, so it's not a very interesting game. So before I do that, before I start playing the game, I need to shuffle this thing. In order to shuffle this thing, well, I can simply call my method from utils. I have this shuffle array, and it is going to shuffle my board.
Why don't we print the board again?
So that's indeed a very good idea. We are going to print. So this is really cheating now because we are showing the answer, but this is going to make developing, developing a lot easier. So that's good. All right. So I'm going to print the board. Now, if I compile that, I'm going to have a problem. And a bad one, so to speak. Here you go. Oh no. What is happening? Marcel, help.
Okay, so although compilers are not so smart, here the compiler was able to follow the flow of instructions and found that there was a way where we could execute this program and we would have never assigned the reference of a board to the variable board. So we need to trick the compiler in some way.
Right. So there are different ways of doing that. I think the problem is here. The compiler knows that you can go into the else branch, and in the else branch the board is not created, and so you would end up with a null board.
One way would be to remove the else.
That would be one way.
Or maybe we could just put a null value in it.
So we could try that.
It's not so smart.
Let's see if
but the compiler will not see that this is a very dangerous thing to do.
So that is an unfortunate trick that we have to play. So now, if we execute that again and say 1 again, and say let's go with 22 again, here you go. So you can see that you have a board that is created and then it is shuffled, and it seems to be reasonably shuffled, right? Marcel seemed to see a logic in this thing. I'm not sure what, but anyways, let's assume it is indeed shuffled.
Yes.
All right. So now I have a shuffled board, and I can start my game. Play game. All right. So play game now is here. I'm ready to play, and then I should play. In order to play the game, so the idea is that we have a board which is there. It has been received as a parameter. By the way, we are passing on all these variables here. You can see that the scanner is passed as a parameter, that the board is passed as a parameter. This is weird. Why am I doing that? And it's just because I want to stick to the Python code in which you were instructed not to use any global variables. And so everything is local to your method. And so you just have to pass everything from method to method. Obviously, in a normal setting, in a normal Java program, you would not do that. You would typically have your board and your scanner in this case as probably instance variables of this class here, and you would just use them.
Yes.
All the time. All right. So that's it. So we have this board. It's an array of character, and we received it. Now we are going to need to have another board, which is the one that people have discovered. We have two boards here. So I'm going to have another array char, which I call discovered, and this discovered is simply the cards that have not been, the cards that have been or not been unveiled by the player yet. So initially they are all covered. So I need to create this array as an array of the same size of the board, and then fill that array with the cards that are hidden, which is a star in this case. So what I do is I just create my new char array, and what is its size? Well, its size should be the same as the size of the board, so it has to be board.length. Okay, so I am creating a board that has this size, and now I need to fill that board with stars because all the entries are so for int I equals 0 and I is less than what discovered dot length, and int I plus plus, and here what do? I simply assign discovered of I gets the character star. All right, now if that works, at the end I should have an array of size the same as the board and that has only stars. I can see that by saying print board, and the board I want to print now is discovered, this board here. So let's see if my code is correct. So 1 12 change a bit. Okay, that seemed to work, right?
Yes.
So I have my initial sorted board, then I have my shuffled board, which Marcel is still trying to crack, and I now have my board of cards that I have not discovered yet. So then what is the logic? So the logic is, at this point we want to ask the user for 2 cards to return, and then there is an entire thing that is done to make sure that the cards that have been selected are okay. That is, they are within the range, they are not already they are different, they are not already uncovered, and so this is really the same thing. So again, I'm just going to copy that for the sake of time here.
So as you copy this, maybe I can point out a very important fact that So far, we told you that you should always be compiling very frequently to detect all possible syntax or type errors. But what Guy-Vincent has been doing so far as well is every time he's been adding something, like here creating the data structure for the masked cards, he's also printing the board. So not only this is a valid program, but it's also a program that seems to be pretty robust, well debugged. So that's also something very important, that not only you compile, but you also test every little bit of code.
Right. So of course, then I have to remember to remove all of that at the end. I'm not going to do it now, but so here I have added this code here, which does so it's not going to work here. So I have a Boolean value here that I use to iterate until the user gives me two values that are correct. So like before, I need to make sure that I am going to go into that loop at least once. So I use this Boolean OK, which I have to declare, Boolean OK, and I need to initialize it to false. Okay, because the first test is not okay. And if you read this, the logic here, you see that okay, this Boolean that suggests that you have to stop looping is initialized to false. Then so it will go inside the loop. Then the values that are read from the users. Then you are going to assign OK to true. So assume that now these two values are valid, and then you can see that in all the tests that you do afterwards, if you fail, you put OK back to false.
Yeah, so you disproved your hypothesis. Your hypothesis was user has inputted something valid.
That's right.
And you prove wrong.
All right.
So maybe P1, P2, are they declared?
So we need also to declare P1 and P2 here. And so int P1 and P2. And P1, I'm just going to start with 0 for them. And I think we use something called guesses. So I'm going to add that as well. Guesses is just counting how many times the user has been playing. Okay, so we have all of that, and this. Okay, this is good. Okay, I understand what happens here. I actually forgot something else. Oops. Let's just push that. In fact, I want to play this until the game is finished. And so this entire logic here should be inside another loop that loops until well, everything has been discovered. Now, if you recall, in the Python codes, it was something like when the equivalent of while discovered is not the same than board. So while there is a difference between the board that you got and the board that you are building by returning cards.
But obviously we spent quite a bit of time in class looking at reference variables in Java, and we know that here that would never happen. Discovered and board are pointing at distinct objects. They will never be the same object.
Exactly.
So that logic would not work here.
So we need to change that, and we cannot do like that. So what we can do is count how many cards have been successfully discovered. And once we have discovered the same number of cards that there are in the board, then we are done.
Yeah, we could have compared the content of the two boards, but that's not very efficient.
That's
Why?
right. We don't want to go over the value all the time, I mean there's absolutely no reason for that.
But that's what the Python code does. It's
Yeah.
it's quite inefficient.
So we are going to count how many cards we have uncovered, and initially we are going to say we have uncovered none of those, and so the while loop is going to be, well, while the number of uncovered cards. Oops, what did I do here again? Something. Okay, how do I get rid of that? Number of uncovered is not the same as the number of elements in my array. Okay, so I have to add the logic for that, which I have not done yet, but I will iterate that loop until I have done all these. I've uncovered everything. So the first thing I will do once I am in the loop every time, if you remember, is to print. So I'm just moving that line now here. So I want to print the board that has been so you can see all the cards that you have discovered already, and then we ask the user for two new values, and once those two new values are provided, if they are and they are accepted here, what we need to do is, for one thing, print the corresponding cards, and the method for that is print revealed. So print revealed, if you remember, has 4 parameters: the array on which we are working, the 2 selection of the user, P1 and P2, and the board, which you still have to pass around all the time. And then, so this is going to print that for the user, and then, well, there are 2 possibilities. Either the value P1 and P2 at discovered match, or they don't match.
Mm-hmm.
If they do match, then those cards are going to stay there. Oops, we apparently have lost something here.
No data.
It's the health is good. Okay, we are back to that. Okay, we are running long here. So you want to print. You have to print this this thing. Apparently, we are having a problem with our streaming here. Do we?
Yeah, it seems to say it's not receiving enough video for the buffering to be adequate.
Okay.
Not sure why.
No, me neither. I mean, this one here seems to be happy. No, now it's okay. No, still bad.
Still bad. Let's assume that it simply means that it's choppy at the other end, or?
Actually, we can see that by going. Sorry.
Oh, okay.
By going here. Where is my
Safari?
My Safari is here.
Okay.
Okay. Well, it seemed to be working here. So sorry. Let's continue, and let's just assume that this is going to be okay. So I need to check if the answers that were provided by the user are good or not. And so how do I do that? I am going to simply say if discovered. So remember that we are asking the user to provide a value between 1 and the number of cards in the game. but this is stored in an array. So the array is actually going from 0 to that number minus 1. So if the user says card number 1, the card number 1 is stored at 0. So we need to go, if discover of, so we need to basically remove 1 to what was provided by the user. So if discover P1 minus 1 is not the same that discovered the P2 minus 1, then basically the answer that was provided by the user is wrong. So if that's the case, then I need to put back the star here.
So you're masking the cards again.
I'm masking the card again. And discovered P2 equals star. And else, what happens? Else, well, this was a success, so I should not touch this this discovered array. I should leave those two cards turned, but I need to say that I have now uncovered 2 additional cards. So else, what is this? Where do I get that? Else, I have number uncovered plus equals 2, or number uncovered equal number uncovered plus 2.
Correct.
And
in all cases, you've made a guess.
In all cases, I have made a guess, so I should go guess plus plus. All right. Now I have actually omitted here. Once you print the value, you have normally to ask the player to give you an input, and you also need to clear the screen. So I'll just do that. Okay. So if that works, we should be fine.
Missing a
probably
parenthesis.
missing a parenthesis right there. And yes, and then we have that. Okay, I have some doubt that this is going to work now, because we have messed around with the code quite a bit, but let's try anyways. Ouch. So guess, oh, that's guesses, not guess.
Hey, quite good.
Well, compiling is
one thing.
Is one thing, yeah. So I want to regenerate rigorous number. I'll say 4. Let's, you know. Okay. So now I want to try to uncover that. So let's say 1 and position 2 2. Okay. So I have. So this is missing the printing. Oh, yeah, okay. So that, no, I know that this is 1 and 3, okay? And, okay, something is wrong. But anyways, one thing is wrong for sure, which is print revealed is doing nothing. In fact, we should have seen our great message here if we were paying attention, saying that it is not, it has not been implemented. I don't see it, but anyways. So print revealed.
Okay. Aha. So there was no message because this does not return anything, so we missed this one.
That's right. So that's the problem. Print revealed is not printing anything, and so it's a bit difficult to play that thing. So the idea here is what? Print revealed is going to, well, put the card that is in the board at position P1 and P2 into discovered, and then print that.
Mm-hmm.
So we will simply go, it's very simple, discovered of what? Again, P1 and P2 have to be shifted by 1, so P1 minus 1 is equal to board P1 minus 1, and discovered of discovered of P2 minus 1 equals board of P2 minus 1. All right. And finally, I have to print this, print board. And the board I want to print now is discovered. So hopefully this will actually print that, and that should work, right?
Right.
Let's give it a quick try. I don't know if this is going to actually work, but the so we said 4. So ABBA, so I'm just going to go 1, and then I'm going to go 4, and it shows me, all right, 1 is okay, and 4 is okay. I press enter to continue. The clear screen did not work for some reason. And I'm going to play 2 and 3. And that worked.
Cool.
Excellent. All right, I think we should stop there because we are already at the 1 hour mark. The code is, the entire code is available on GitHub. We'll put the link on Piazza.
Yes, maybe we can modify the actual page where we published the assignment to have a link as well.
That's right.
So we'll do all that later today.
And by the way, you will also have the code for that we used last week there. Okay, and what you will find there is also a version that is slightly objectified of the same assignment. So not a lot, but at least you will get something like the concept of a card is going to be an object now instead of being a character. So the card itself knows whether it's uncovered, and so you don't need to have 2 different arrays to store this data. You just have 1 array of cards, and the card have these variables saying whether or not they are uncovered. And then you have a deck of cards, which is itself an array of an object which contains an array of reference to cards. And so you can look it up. We want to have a quick
one last thing maybe would be to look at the assignment 1.
All right, let's do
a first time.
Let's do this. So here the goal of this assignment is going to be to do this kind of curve fitting. So the question here is, if I have data in any number of dimensions, but let's say on the plane right now, I have data everywhere. Can I find a curve that sort of goes through these points more or less closely? Okay, so depending on how these points are, the line may have to be more or less complicated.
Yes.
But they are, if you compare lines, you have some lines that are closer to the set of points than others.
Yeah, so as input you have a cloud of points. And now you would like to have some curve that would be representative of these points. So you can assume that the points were actually generated by some mathematical model.
Yes.
And the simplest of all the possible models would be that it's a linear model, so that the data was generated from a straight line.
That's right. So you have these points, and now the question is, okay, what would be if you try to fit this set of points with just a straight line? How would you find this line?
Correct.
Now, if you have the coordinates of all these points, you can just resolve the correct equations to find this line. For sure, you can do that. There's no fun in that, but you can do it. Much more interesting would be to write a program that is going to look for the best possible line.
that would actually learn from the data.
It would learn automatically, look at the data, and then try by iteration, try to find a good solution. Now, what would be a way to do that? How about this? So I have a bunch of points. Let's have a quick look at the example here. So this is taken from Wikipedia. You can see that in blue you have points, and here you have a line that fits it, and the red line is sort of going through the points here. So the question is, how can I find such a line given the points? How about the following idea? I take my points and I just randomly draw a line.
Mm-hmm.
Take a line at random, draw that. And then I'm going to see how far it is from the point. Yeah?
And you would expect that it would be a pretty bad solution
It might
because
be a
it
bad
was
solution.
randomly generated.
You would expect
be a
it
good
to
one,
be
but you have to be pretty lucky.
awful solution. But okay, that is solution. So I can look at that and see how good it is. Now, what does it mean? How good it is? Well, I have to find a way to measure, you know, the fit of that line for the points. And I have different ways of doing that. I can, for example, look at the distance, the average distance of all the points to the line, or maybe the sum of all the distances to the line. Something of does not really matter to me at this point, but I can say how good a solution it is using one of these formula.
Yeah, it's a measure of agreement.
Right.
How well do the points agree with the line?
That's right. So now I have this line. And that's my current solution. Maybe it's quite a bit, but that's my solution.
Mm-hmm.
Now, what can I do? I could do something a bit silly, which is, okay, let's just draw another line.
Yeah, if you have infinite power, you could...
I do.
You could actually randomly generate new values for the parameters, and then eventually, if you find a solution that's close enough, then that would be the solution.
That would be
that's probably
that's not efficient.
not very smart.
That's not very smart, not very efficient. But it is still interesting to realize that, well, actually, if I draw a random line, and then I draw another random line, if the new random line is better than the one I had before, then that's my new solution. And I keep doing that. And by just drawing things at random, I can actually go toward the solution. Now, it's going to take a long time. And in fact, the best my current solution is, and the more time I'm going to draw a random line before I find a better line. But interestingly enough, it will still work. Eventually, you will keep improving on your solution. But the problem with this approach is that I'm not building really on what I know. If I have a line, I don't use the knowledge that I got from that best current line in order to find an even better solution.
Mm-hmm.
What would be probably a good idea is I start from a line, which I draw at random, and then I nudge it a bit. So instead of just drawing another line at random, what I can do is move it a little bit, to the left, to the right, move it just a little bit and see in which direction I am actually improving. If I do that, you can see that I will almost certainly, at least at the beginning, almost certainly at each iteration, by doing just a little bit of nudging in 2 or 3 different directions, find the one that is improving,
Mm-hmm.
and then I am constantly improving. So I'm actually pushing now, and now it's not so silly. It is actually pushing towards the solution.
Yep.
Now, still some problems with this sample approach here, but I think it's rather interesting to think that this will actually give you a solution. You start from something drawn completely at random, and then you just iterate, improving it until you find something. And that, with a better algorithm, is what we're going to do.
Correct. So here, what would be a better strategy for making these small changes to the parameters of the model? So we need to find a direction in which we should be moving.
That's right. The direction. So if you think about it, a line is an equation, right? Y is equal to A times X plus B would be your
In this
equation.
case, yes.
And so there are two parameters that define your line, A and B.
A and B.
One defines where it's crossing the axis, and the other one is defining the angle.
Correct.
So you can change both A and B at every iteration, and the goal would be to change A and B so that the line is better. What you can do is look at the error, so how far you are from the point, as a function of this A and B. And you call that an error function, let's say. So it gets, for each possible A and B, it gives you how far you would be from your point, with some definition of being far.
Mm-hmm.
And that, in turn, gives you a function. And because it measures how good your fit is to your point, what you are trying to do is find the smallest possible value for that function. In fact, if you can find a line that is going to go through all the points, which probably you can't, although the points happens, unless the point happens to be aligned in the first place, but you can find a value which is the minimum value. So such a function usually, could have any kind of shape, but here it so happens that it's going to be a kind of a ball here. It's going to have just one minimum.
Which is going to be very advantageous here.
In this case, that is going to be great, yes. And so, well, if you look at a function like that and you are trying to find a minimum, what you can do is use the derivative. So you are somewhere on that line, on that shape, and you are trying to move towards the minimum. Well, if you look at the derivative of the point on that line, well, the derivative is basically telling you in which direction it's going.
It's pointing towards the optimal.
So it is indeed showing you where to go.
Mm.
So you can use the derivative to decide how you want to move both A and B so that it's going to go closer to this optimal, this minimum value for the error function.
Correct.
So this is what we are going to do. We are going to provide you with, there is a little bit of some explanation of the mathematics beyond that. But so this is really what this assignment is. You have to implement this so-called linear regression here, where you are going to iterate following the derivative of this error function, and you are going to do that until you are happy with your solution. The trick here is, it is explained what you are going to do, and there is enough information here for you to understand why you are doing that. But don't be alarmed if the math is not your thing, and you don't quite understand those steps. That's fine. Just this, at the end of the day, this is the formula that you must implement in order to get a solution. So it is better to try to understand why you are doing it, but you absolutely don't need to understand it in order to implement it.
Correct. So here basically what the algorithm that you can see on the screen is saying is that it's going to be iterative. So there's going to be a bunch of iteration. Initially we started from a solution that could be pretty far from a good solution. It's a very simple model that has two parameters, and with every iteration we're making small corrections to each of the parameter. In which direction? In the direction that's given by the partial derivative with respect to each one of these two parameters. And we keep iterating. every time we're moving slowly the value of these parameters. Here there's a parameter called alpha that controls how fast we are doing this thing, how eager we are to converge towards the optimal solution.
Right.
And that's actually a very general solution. So this is an optimization problem.
Right.
We're trying to find optimal values, and you can reuse this all over the place during your studies.
Absolutely. I mean, those of you who are going to take any class in machine learning, this is going to be the first thing you're going to learn there. So you are learning in advance of that. Alpha, so just a point regarding alpha, by the way. Yes, alpha, the measures how eager you are to find the solution. Of course, there is a catch. If you use an alpha that's too big, you are going to be too eager. You are going to jump over the optimal solution, and you are actually going to worsen the solution at every iteration.
Yes.
So you have to, you need to try to find the alpha which is as large as possible, but not too large. And the alpha we are talking about here are going to be pretty small. Shall we just show a little demo of that?
Correct. Okay, so we're just going to move around a little bit.
So while we do that, so we have provided with the assignment, we have provided a method, a class that you can use to visualize. Yes, SRC. To visualize the progress.
Okay, so it's already compiled.
So assignment. All right, so it's on the wrong screen. Just 1 second. Okay.
This should work, right?
That's right.
So what do we see?
Yeah. So what we see here is, so first, these dots here are the input points. The input to the algorithm. What we are trying to fit.
And maybe actually in this particular example that's shown here, what I think you've done, because you wrote the code, is you first created a line randomly, which is the dark line.
Yes.
So the line was created
randomly. So I just choose a line at random.
Then you generated the cloud of points. You didn't want the points to be only on the line, so you introduce some vertical noise. So each point is moving above or below the line by some random value.
That's right.
Which is well controlled, that you call the noise here.
That's right. So you have a random line. On the random line, you randomly choose points. And on these points that you have randomly chosen, you add a little bit of a noise so that the value that you give to the algorithm is not the exact value that would be the line, but somewhere relatively close to that. And this is also randomly chosen.
Yes, and here that may look a little bit silly at first. We know the parameters for the line, but what you have to think is that this is a testing framework. We want to see if the method is working. So that's why we first generate the parameters for the line. We generate points, and then we will try to recover the parameters of the model. In reality, in a real world application, what you would get is just the points, and you would like to find the line.
That's right. So here you can see it's actually telling you quite a bit. So the current hypothesis, what is that? Well, that's my line that I am using. So initially I'm just, I have to start somewhere. I could draw a random line, but instead I start with y = 0. That's the red line here. And that's where we are. That's our first fit for that set of points. It's clearly a bad fit, and you can see here the current cost is very high. And this is what you see here aiming for. Well, it displays the line that has been randomly generated by the algorithm. So this is what we are trying to find. And at iteration 0, so we have this thing. And then if I click return here, this, you can see that now after 100 iteration, the line has started to move in the right direction. And now the error has gone down quite a bit. And this is the what I have right now.
I don't think they see what you see.
They don't see what I see.
Okay.
Now they do. This is the equation of my red line here, and this is what I am trying to find.
Mm.
And if I keep going, every time I click here, you can see here the red line is approaching the exact solution, and so on and so forth. So I will keep going until I'm done. I've done the number of iterations that is programmed here, or normally you would do that until you are happy with your error, or at least until you are not making any progress, because the error, well, it depends how how aligned those points really are, and you are not going to go below a threshold, which is controlled by the actual location of your points. But what you can control is the amount of progress you do every time you try to nudge that line a little bit.
Yeah, so clearly the error cannot be reduced to 0
because it's not a line.
It's not a line. And so this assignment has two parts. A first part where the data is generated from a model that's linear, and there's actually one free variable. So we're on a plane. That's
yes.
Part 1. And then part 2, we're generalizing this idea.
Yeah.
I actually quite like the example that you're giving in the description, where you're saying that such framework could be used for predicting the price of houses. So you would go in the neighborhood and you would collect data. Initially, you may think that the size of the house is a good predictor of the price, and you would collect information about the size of the houses. So for house number 1, you have the price and you have the size.
And that's 1 point in
and that's
in
1
plane.
point. You go to the next door. What's the size of your house? What's the price? And you do this for a large number of examples. And so we would take this data, use the algorithm that's proposed here. We would actually find a linear regression for these points. And then when a new customer is coming to you and is saying, what should be the price of my house? You will ask, what's the size? And we will give an answer.
And the model is going to tell you the house is going to sell for that much.
So that's a very naive way of setting the price of houses, probably. But in the second part of the assignment, we're generalizing this to many dimensions, many features, or many attributes. And so other things that we could be measuring could be the number of rooms in the house. Is there a garage? Is there a swimming pool? Or so
any number of
any number. So we could have a n-dimensional problem now, where we have measured various attributes of houses, and we would do the same thing. We go to the neighborhood. What's the price of the house? What are the values of all the features? Collect the information, and then
use our program again.
Use the program to estimate the parameter of a generalized linear regression
Of that, and then you would, when a new customer comes in as a house for sale, you can ask for number of rooms, garage, swimming pool, size, location, all the parameters, and then this time the model is going to give you an answer which is probably quite realistic.
yeah, could be quite realistic. And in machine learning, there's this thing where you should always start with the simplest model. You should never invoke a very complicated model. So the simplest model often is to assume linearity. That things are linear.
Absolutely. All right, so this is going to go up on the website very soon, probably today.
Probably today,
And
otherwise tomorrow.
otherwise tomorrow. And so we hope that you are going to have fun with that. And so don't be alarmed by the math behind it. If you don't understand, you know, just code it, and don't wait the last minute to do that. It is not a lot of code, but it's going to take you a little time to get it right. So if you start now, you're going to be fine. But if you start the day before, this is not happening before the deadline. And of course, you know, use Piazza. Come to see us with questions.
Mm-hmm. And so we're hoping that we can actually save more than 1 hour of video. Otherwise, the 17% that are watching are the lucky ones that are getting all the information.
All right. Have a good weekend.
All right. Bye now.
Bye. So stop streaming here.
Boom.